Anybody else been practicing their ninja skills while they've been out?
Man, I'm a weirdo, aren't I? Did you laugh? Hopefully so. If not, that's all right. No worries. But so I, yeah, sort of more serious note, right? So welcome back to the digital world, right, of online learning, right? The learning of the future. So basically what I just want to explain to you is I've sent a video out before, and one of the things I want to make note of is if you hand in an assignment and you get everything wrong, you're going to get full credit, all right? So essentially for you, which is kind of nice, is that it is an effort-bearing course. The only way you're not going to get full credit is if you hand something in past a deadline. So, for instance, today, okay, 3:30. I'm only giving you 3 problems, so I want it turned in today just to practice it, get you in the habit of how you're going to turn it in. But in the future, I might make assignments that are handed in later, like a week later. The goal is to give you some leniency so that you're not inundated with work all at once. I mean, the beauty of this platform is the fact that you can complete the work when you feel ready to sit down and learn the material. So with that being in mind, right, I'm going to do a video here, and this video is going to be on our new topic. You are skipping 2 topics in our packet. We'll come back to do practice problems in our packet. That's what we'll do tomorrow, and I'll do some examples on here with you. But the point of this is that the topics that you skip, don't worry about them. We've been in contact with the high school. We've talked to the pre-calc teachers. We've all met, and we're talking about like what are essential things, where do we need to be, and the pre-calc teachers have decided to adopt some topics that normally would have been taught in the Algebra 2 that hopefully next year we're back in the classroom, or maybe we'll be back in a little bit sooner, but the goal is that they're going to take over those topics. So either way, yeah, I just wanted to let you know that. So don't worry about the topics we skip. We're going to jump into rational exponents. So here we go. All right, so here we go. We're going to go and get started on rational exponents. So one of the first questions we have to answer is just what does it mean to be a rational exponent, right? And what are their equivalencies to, like, are there rules for them and things like that? And then, not in this video, but moving a little bit later in the week here, we're going to jump into simplifying expressions with rational exponents and how you have to leave their answers. But this video is just meant to hit this first target of what does it mean to be a rational exponent, and are there equivalent expressions? So let's go ahead and answer that question. Okay, so first things first, we're studying rational exponents, so let's just review what the word rational numbers are. And rational numbers, over here to the right of your screen, you'll see I've written out there. I don't know which your teacher taught you it as, but I'm just going to give you the formal definition. It's any number that can be expressed as the quotient of 2 integers, right? So essentially, you take 2 integers, a quotient is a division problem. So if you take 1 divided by, say, 2, you get 1/2, and you can't simplify it, right? Fractions, we have properties of simplifying, so it's a fraction. So notice when you write a quotient, it's written as a fraction. So there you have it. What we are going to now study is what happens if I have a base and its exponent is a fraction. So in the past we talked about your natural numbers, and then I gave you this scenario of 4 to the 0 power. Now normally I use a 2 for this, but this time I'm using a 4, right? And we have this problem. You have 4 to the 0 power and you have 4 to the negative 1. And basically I just want to show you what we have. And basically we've created a set of numbers where we kind of are making a number line here. Like if you think of this as negative 1 and 0 and making a number line sort of here, right? I'll erase this in a second. And there's 1 and there's 2, right? Does that make sense? Then your first set of numbers you begin to learn about when you're younger is the natural numbers, and then the whole numbers get added to your set, and then the integers, and then all of a sudden your teacher says to you, well, it's a line. Lines go on forever. They're continuous. So what about the stuff in between negative 1 and 0? And then you begin to learn that those are called rationals because they're not quite whole amounts, so they're partial amounts. So rational numbers are the partial amounts that are essentially in between your integer values. So let me get rid of this number line I drew here. And we're now going to insert one of the first fractions you learned about as a kid, and that was 1/2, right? So 1/2 falls in between 0 and 1, so 4 to the 1/2 power. And the question of this video really just becomes about, well, what does 4 to the 1/2 represent? Like, what is it? And that's what we're going to answer in this next video as we come along. So it's actually a kind of cool thing, but hang on there, all right? Okay, so what is this mysterious thing? What is this rational exponent? How can it be rewritten? Well, I chose 4 for a reason, and I'll show you why. And the reason why I did it is because 4 can be rewritten as something else. Meaning I have 4 to the 1/2 power, but 4, if I take a look at its factors, right? 4 can be rewritten as 1 times 4, but 4 can also be written as 2, okay, times 2, which is going to be kind of important, all right? And maybe you can guess this before I get to the end of my punchline here, right? So notice when I take 4, and I'm not going to use 1 times 4 because that does nothing for me. It just leaves me the 4, right? But if I rewrite this thing as 2 squared to the 1/2, right? All of a sudden, I can now utilize what is known as the power rule of exponents. Right? And notice what happens when I take the power rule of exponents. And the power rule of exponents, okay, just remember, is you get to multiply these two exponents. So the answer to this is 2. So 4 to the 1/2 power equals 2. What equivalent thing is doing that? Did you get it yet? All right, so here's the answer, right? So ironically, okay, these number sets began the study and they came up with this too, right? But then they started going, well, what about the, other stuff? All right, what about that? Now 4 is special, right? Because if I had did 2 to the 1/2, all right, unfortunately 2 cannot be written as anything but 1 and 2. So it began the study of what is this? What do those represent? And what they began to understand is if you look at ones that were special, okay, you notice this 4, okay, is a special number. You got it, it's a perfect square. All right, so what we begin to notice here is that that's a perfect square, and notice that the answer was 2, which ends up being what is called the root of 2. So here it is, 4 to the 1/2 is also known as a square root of 4. All right, so there is your equivalent form. So now we're going to talk about very quickly, I'm just going to give you some things so you understand it, how that conversion takes place. All right, but here it goes. So notice the base of a rational exponent is also going to be what the radicand is. Okay, so every base gets converted to the radicand of a radical expression. And then the other thing you need to notice is the numerator, it still exists. You just don't see it. It's 4 to the 1st power, right? And now a square root is what root? Well, it's the 2nd root. So now there's a couple things we don't write. One, we don't write a 2nd root, and we usually don't write things with 1st powers. So just so you're aware, okay, we're going to do some more examples a little bit later here, but I just want to let you know that indeed a rational exponent, okay, a rational exponent is actually going to be represented by an nth root. All right, so let's explore just doing some conversions. But before we do that, there's one small thing we have to do, and that's just a quick review of your fraction skills because they're going to help us a little bit later in this video. All right, so the fraction skills review that I need you to know is basically writing a given fraction in another equivalent form. So first off, let's write 3/2 to another equivalent fraction. It's just bare basic stuff here, right, since you were little kids. So what you do to write an equivalent fraction is you simply multiply both top and bottom by the same thing. So let's multiply by 2 and 2, right? And there you have it. 3 times 2 is 6, and 2 times 2 is 4. So 3 halves is the same thing as 6 fourths. So they're equivalent, just in different forms, right? So that's just the bare basic. Remember, to convert a fraction into a new form, you must multiply by what is called the power of 1. So just remember to multiply both numerator and denominator, right? And then we have the next skill, which would be, hey, let's take 1/2 and 3/5 and write them with the same denominator. To do so, you would look at the 2 and you would look at the 5 and you would say, okay, what can I turn 2 in that I can also turn 5 into? The algebraic method to this would just simply to be look at the factors of each. Well, 2 is prime and 5 is prime, so therefore if I give that a 2, we then convert that into 2 over 2 because you multiply top and bottom. And then I just give this a factor of 5, and lo and behold, there you go. What you have is that you've now got 5 over 10, and you've now completed the task and got 6 over 10. Again, the only task there was to write the denominators with the same denominator. Okay. Now you'll understand why later that's important, but for now, those are the fraction skills you need to have to be able to do. All right. So let's go ahead and move forward. So our first example is going to be something like, okay, what is x to the 3/4? And how can I write this in radical form? Write this, okay, in radical form. All right, now for the problems that you're doing, you're always going to have the direction of which one you should do. So we're going to write this in radical form. So here's how this works, okay? The denominator always represents the nth root, okay? And the numerator, okay, will represent the exponent, okay, of the base. So in this case, the base is an x. So when I rewrite this, I'm going to write a radical. All right, the nth root, remember the root of a radical is placed in front of the radical symbol. So this will be the 4th root of, okay, the base of x. And this 3, the numerator of the exponent, will just be the exponent of the base. And there you have it. It has now been converted. So what you need to know is that in radical form, if you're going to take a note, right, like if we want to use an a, kind of like they do in Algebra 1 a lot, that a, right, the denominator is the nth root, and the numerator is the exponent of the base. Okay? So, and this guy right here, a, that is called the base. Right? So you have those as notes if you want to take those, and that's how that works. That's how you turn them into radical form. And then understanding that things can be written the opposite way. So if I really wanted to, okay, I could rewrite this expression here, and I would rewrite it as, here's my base, all right, the numerator, so this number is the exponent, so that would become the numerator. The denominator would be the root. So there's the root, so it would be the 4th root. Okay? All right, let's continue on. Let's just do some more practice. So let's do another problem, and this time we'll have 2 variables, right? So what happens if I have x to the 2 thirds and y to the make it 1/3, right? To the 1/3. All right. So I want to write this together, right? So the goal is to actually put this together, and when you put it together, the goal is going to be to have one radical. So I want to convert this to radical form. All right. Now, when you convert this to radical form, what you need to know is the most important thing about this is you can't have multiple radicals, right? It's radical form, meaning that my answer, I only want to have one nth root. So basically, underneath here, see the denominator? What's important is that all the nth roots match. Like this is the 3rd root, and that's the 3rd root. So when they all match, all right, that's when we now know we have one single root. So for this problem, just so we have it, right? So these are all 3's, so that's the third root, right? It's called the cube root. Now, again, now the numerator stays the same. My first base was an x, and its numerator is a 2, so the exponent is a 2. The y was my second base, and its exponent was a 1. So it's y to the first power, which more commonly nobody just writes it. So now I'm done. This is written in radical form. Now again, if I wanted to convert this the opposite way, right, like if I want to put it back into rational form, it's pretty simple. You take the variable you have, so x, and you take it, and it's a square, so x squared, just remember that's the numerator, and you write its exponent over the nth root. So the root here is the third root, so it becomes x to the 2/3. The exponent on the y is a 1, so when you don't have it there, it's important. You do need to do it. You need to place it in there. So it'll be 1/3. And now notice, I took it, and I converted it back into its form. So what's very important here is that you see it happening both ways, but the goal here was for my answer was to get to here. Okay? All right, let's do another one. All right, let's do one with a leading coefficient here. So here we go. All right, so 4. So what we need to know is that a coefficient is also a base, and every base has an exponent. So that's very important that when we have coefficients, that we put their exponents in there. So this is 4 to the first power. So in other words, because we're in rationals, I don't want to just write it as 1. I want to write 1 as a rational expression. So that becomes 4 is 1/1. And you have x to the 1/3, y to the 5/3, and z to the 7/3. Okay? So now, here's the deal. When you involve different numbers and you involve a coefficient, most coefficients are going to always have an exponent of 1, right? So the problem with this one is that when you write something under radical form, you can only have one radical. Like I can't have multiple radicals here because then that's not reducing. So we want to put something, if it can be written as 1, we do that. And the power of converting fractions into other numbers is what enables us to write it as 1. So we're able to write it as 1 radical, so therefore we do that. Okay? So 1/1. Okay, we just want to have all the denominators be the same. Notice they're all currently 3's except for the first one. So we'll rewrite this by multiplying top and bottom by 3, and then we'll establish that 3 as the denominator. So this is 4 to the 3/3, x to the 1/3, y to the 5/3. Sorry, missed the little 3 up there. And z to the 7/3. Now, with time, you may learn just to jump right to there. Like, I've done these for so many years now that I jump right to that step down here of 3/3. I don't really write it as 1/1, show the work. And if you get there at some point, awesome. But anyhow, we're at the last step here. So they're all the third root, so the nth root of 3. And then I write their bases. So 4, numerator exponent is 3, x to the first, and then really writes that. No harm, no foul. If you write it, not going to worry about it. X to the 5th, numerator, and z to the numerator is a 7. Okay? So now there is one small thing that I'll do, and I will clean up the base with the number. So 3 and 4 to the 3rd power, we can figure out is 64. X, y to the 5th, z to the 7th. Now, there is something I would like you to do. I would like you always to write the number as its multiplied value. Don't leave it in the number base in exponential form. Please do write it out so that it is multiplied out. All right? Thanks. On to the next one. Okay, so last but not least, we're going to save the toughest one for last, and this is the one where you will need your fraction skills. So let's take a look at a problem. Let's say someone gives me a problem, and they say, hey, Mr. Mayor, what is 2x to the 3/2 and y to the 1/5? What could that be in radical form? Okay, so my goal is to convert this to radical form. So remember, to convert something to radical form, I kind of alluded to it in the first in the last problem I just did there, in which I noticed that 2 to the 1st power, right, messed everything up, because if you express 1 as a rational number, it's 1 over 1. And unfortunately, what messed that up is that the other numbers had 2's in the bottom, and that had a 1. Well, notice now I just increased the difficulty of the problem, because now all of my numbers and their denominators are different. So what I have to do here is I have to employ the strategy of like when you would add, okay, when you would add fractions, and I just have to create a common denominator. So basically at this point I'm doing fraction conversions to all having the same like denominator. So essentially what I'm going to look at when they're numbers, okay, I can just do it by what is called the GCF, which is the greatest common, not the greatest common factor, by the LCM, which is called the least common multiple. So for most of you, I think at this point you should know that the common denominator of this fraction should be 10. So I need to multiply, so 2 to the first, okay, becomes that I need to multiply top and bottom by 10, and for the 3 halves, top and bottom gets multiplied by 5, and for 1/5, top and bottom get multiplied by 2. So I'm going to go ahead and do that. So 1 times 10 is 1, and 1 times 10 is 1. And then x to the, well, 3 times 5 is 15, and 2 times 5 is, you got it, 10. And y equals 2 times 1 is 2, and 5 times 2 is 10. So now what I have here, all right, is the all-important case and scenario is that every single one of these is all written to the same nth root. So the root, the nth root I have will be the 10th root, okay, of, well, the way you do this problem is 2 raised to the 10th power, okay, and then x to the 15th power, and y to the, remember the numerator is its exponent, 2nd power. Now you can do one tiny little cleanup of 2 to the 10th power, and if you take out your trusty dusty handy calculator, good old calculator, do 2 times 2 times 2 times 2, 6, 7, 8, 9, 10. You get 1,024. So just cleaning this up a little bit, I will take the 10th root of 1,024, x to the 15th, y squared. And there you have it. I've completed it in radical form. So I'm just going to give you 3 practice problems, see how you do with them. I'll give you the beginning, the middle, and the end. All right? All right, so here are your 3 practice problems. So these are the ones I want you to write down, okay, and I want you to do them. All right, so it's 3 practice problems, and what I want you to do is I want you to convert, okay, the rational exponent, okay, into its radical form. Okay, so here we go. Number 1. Let's just start off with an easy one. Let's do x to the 1/3, y to the 2/3. So write that in radical form. Okay, so there's one problem. The second problem. All right, the second problem will be, let's make it a little bit harder, and let's turn it into a having a coefficient. So here we go. Let's do 2. And we'll do an m in this case, so m to the 1/4, and we'll do n to the 3/4. Okay, so convert that into radical form. And then last but not least, we'll make it the most difficult of them all that I gave you. Let's say we had 5 x to the 2/5. I'm not use 5. I use a bunch of 5s today. Let's do something else. Let's do 2/7, and let's do y to the 1/3. Okay, so maybe a little bit of a challenge there for you, but I just want you to simply convert these to radical form. When you're done, take a picture of them. You can do mental work for all of them. There's not really a whole lot of work you have to show. If you do want to show work, please feel free to. If you want to do the conversions, not a problem, but you could do some of this with mental math for me. But take a picture, submit it, and let's see how you did. All right, let's see if the lesson made sense or if I need to clean up my instruction here. All right, thanks, guys.